Good morning, sir.
Good morning, sir.
Good morning, sir.
Yeah, good morning, all. Are you guys having any doubts with the previous class, or else shall we move forward to the new topic?
Yeah, continue with the new topic, sir.
Yeah, Subramaniam, are you able to fix that issue?
ఎస్ చేశాను సార్. అది ఇమేజ్ నా అంతా రాలేదు సార్. మీరు ఇమేజ్ ఇచ్చారు కదా దాంట్లో చేశాను సార్.
కాదు, ఇది లింక్ రావట్లేదు కదా
ఆ
కంటైనర్కి.
యూఆర్ఎల్ అది రావట్లేదు సార్. లింక్ రావట్లేదు.
మరి ఫిక్స్ అయిందంటున్నా.
రమ్మనింగ్ అంతా వస్తుంది. లింక్ రాలేదు సార్.
ప్రొసీజర్ మాత్రం సేమ్ యాక్చువల్లీ నా దాంట్లో మళ్ళీ నేను 2 టైమ్స్ మళ్ళీ ట్రై చేశాను యాక్చువల్లీ సేమ్ మెథడ్ నా దాంట్లో వర్క్ అవుతుంది.
ఆ లింక్ ఒకటే రావట్లేదు సార్. పోస్ట్ రావట్లేదు. కొంతమంది వర్క్ అవుతుంది.
ఒకసారి మళ్ళీ చూద్దాం ఈరోజు. ఓకే.
సరే.
ఓకే, ఫ్రమ్
Sir,
టుడే ఆన్వర్డ్స్. యా, చెప్పండి అన్న గారు.
yeah, me, sir, Venkatesh.
యా, చెప్పండి.
Yeah, from these topics, I have understood like uh, we have deployed the website in three different ways. That's it, sir.
వెబ్సైట్ డిప్లాయ్మెంట్ అనదు,
Like
కంటైనర్ డిప్లాయ్మెంట్ అనాలి.
website hosting, like in three ways, using WinSCP tool, and then ECR and Docker Hub. The whole
ప్రీ
concept. Yeah,
కరెక్టే.
that is what I understood from these practice from the
రైట్,
previous
రైట్,
classes.
రైట్. సో ఇక్కడ ఏంటి అంటే నౌ దిస్ ఈస్ వాట్ వీఆర్ డూయింగ్ రైట్ నౌ ఈస్ బేస్డ్ ఆన్ కంటైనర్స్ అనమాట. సో దిస్ ఈస్ న్యూయర్ కాన్సెప్ట్. సో రైట్ నౌ ఆల్ దిస్ organizations are working on these containers only. So mainly when you are into this DevOps side, so mostly your work will be on this based on the containers only. Okay, so previously we used to have this servers concept. So now the servers concept is still there, but the thing is, there are the traffic to the server is more nowadays. So in the previous time they used to handle by keeping multiple servers. So right now what they are doing is the same job is taken care by containers. సో అందుకే మనం కంటైనర్స్ పైన ఎక్కువ ఫోకస్ చేస్తాం. సో ఫస్ట్ ఇఫ్ యూ మన కంటైనర్స్ కాన్సెప్ట్ అర్థం అవ్వాలి అంటే ట్రెడిషనల్ మెథడ్లో ఏం చేస్తారో అర్థం చేసుకోవాలి. సో ట్రెడిషనల్
Okay.
మెథడ్లో దట్ ఈస్ ద రీజన్ వీ హ్యావ్ క్రియేటెడ్ సర్వర్స్. ఒకసారి విండోస్ సర్వర్ క్రియేట్ చేసాము, తర్వాత యూబంటూ సర్వర్ క్రియేట్ చేసాము. సో అది ట్రెడిషనల్ మెథడ్. సో దాని తర్వాత ఇప్పుడు లేటెస్ట్ మెథడ్లో ఎలా చేస్తున్నారు. సో ఈ కంటైనర్స్ వచ్చాయి. సో కంటైనర్స్లో అన్నిటికన్నా ఈజియెస్ట్ మెథడ్ లైట్ సైడ్లో చేసాము. దాని
Yes,
తర్వాత
sir.
మనం ఈసీఎస్లో చేసాము. సో ఈసీఎస్ ఏంటి అంటే దిస్ ఈస్ ద సర్వీస్ ప్రొవైడెడ్ బై ఏడబ్ల్యూఎస్ సెపరేట్గా. సో నెక్స్ట్ వచ్చేసి ఏంటి అంటే ఈకేఎస్. ఈకేఎస్ ఏంటి అంటే ఓపెన్ సోర్స్ టూల్. సో ఇంతకుముందు మనం యూబంటూలో ఎలా చేసాం, విండోస్ ఆపరేటింగ్ సిస్టమ్ చేసాము, యూబంటూ చేసాం. సో ఈసీఎస్ విల్ బి ఫాలోయింగ్ అండర్ ఇది. సో ఏమంటారు, కమర్షియల్ సాఫ్ట్వేర్ లాగా, అంటే ఇట్ విల్ బి పెయిడ్ సాఫ్ట్వేర్. సో మళ్ళీ ఈసీఎస్లో కూడా వీ హ్యావ్ డన్ టూ మెథడ్స్. వన్ ఈజ్ మేనేజ్డ్ మెథడ్, వన్ ఈజ్ అన్మేనేజ్డ్ మెథడ్.
Unmanaged
సో
Fargate.
అన్మేనేజ్డ్ మెథడ్లో ఏంటి అంటే ఎవ్రీథింగ్ విల్ బి టేక్ ఆల్ యువర్ సర్వర్ కెపాసిటీ ఎవ్రీథింగ్ విల్ బి టేకెన్ కేర్ బై ఏడబ్ల్యూఎస్. బట్ దానికి ఏంటి అంటే ఫార్గేట్ అనే నేమ్ ఇచ్చారు. రైట్. సో ఇక్కడ ఏంటి అంటే వెన్ యూ ఆర్ యూజింగ్ ఫార్గేట్ యూ నీడ్ నాట్ క్రియేట్ ఎనీ ఇన్స్టాన్సెస్ ఆర్ సర్వర్స్. సో ఏం చేస్తుందంటే ఏడబ్ల్యూఎస్ విల్ క్రియేట్ దిస్ ఇన్స్టాన్సెస్ ఆర్ సర్వర్స్ బిహాఫ్ ఆఫ్ యూ. సో ఏంటి అంటే ఫార్గేట్ సర్వీస్ మీరు యూజ్ చేసేటప్పుడు నీ వెనకాల ఎన్ని సర్వర్స్ ఉన్నాయి, ఎన్ని ఇన్స్టాన్సెస్ ఉన్నాయి, నీకు సంబంధం లేదు. సో నీ దగ్గర ఎన్ని కంటైనర్స్ ఉన్నాయి, ఎన్ని కంటైనర్స్ డిప్లాయ్ చేసావు, ఎన్ని కంటైనర్స్ రన్ అవుతున్నాయి. సో ఓన్లీ రెస్పాన్సిబిలిటీ ఇస్ మేనేజింగ్ యువర్ కంటైనర్స్. సో అదే ఇప్పుడు
Okay.
నార్మల్గా మేనేజ్డ్లో వెళ్ళామనుకో, సో యూ నీడ్ టు క్రియేట్ instances
Instances.
and you need to deploy your containers into these instances. So అందుకే while doing our practical also we have faced one issue. సో అప్పుడు ఏమైందంటే ఒక్క ఇన్స్టెన్స్కి ఓన్లీ వన్ కంటైనర్ మాత్రమే రన్ అవుతుంది. సో సెకండ్ కంటైనర్ రన్ అవ్వట్లేదు. సో వీ హ్యావ్ ఫౌండ్ అవుట్ దట్ పోర్ట్ నంబర్ ప్రాబ్లం. సో ఈ పోర్ట్ నంబర్ మళ్ళీ ఎవరు అసైన్ చేయాలి, మనమే అసైన్ చేయాలి.
మనమే.
సో మళ్ళీ సమ్ టైమ్స్ ఏమొస్తుంది, హార్డ్వేర్ ఇష్యూ వస్తుంది, హార్డ్వేర్ రిసోర్సెస్ సరిపోవట్లేదు. సో మనము T2.micro అంటే హార్డ్లీ వాడు ఒక 512 MB ర్యామ్ ఇస్తున్నాడు. సో మనం ఇప్పుడు ఒక 512 MB సైజ్ కంటైనర్ డిప్లాయ్ చేసామనుకో, సో అది సరిపోదు, సో డిప్లాయ్ అవ్వదు. సో అప్పుడు మళ్ళీ ఇప్పుడు ఇన్స్టాన్సెస్ సైజ్ మనమే పెంచాలి, అండ్ ఇప్పుడు మన కంటైనర్ది కూడా మనమే హ్యాండిల్ చేయాలి, రిసోర్స్ కూడా. సో ఏంటి అంటే దిస్ ఇస్ మేనేజ్డ్ థింగ్. అందుకే నేను ఫార్గేట్లో మనం ఫార్గేట్ చేసేటప్పుడు ఏం చేశాను, ఎట్ ఏ టైమ్ ఐ హ్యావ్ డిప్లాయిడ్ 10 కంటైనర్స్. సో 10 కాదు, ఈవెన్ ఇఫ్ యూ డిప్లాయ్ 100 కంటైనర్స్ ఆల్సో ఇట్ విల్ యాక్సెప్ట్. వై? బికాస్ ఏడబ్ల్యూఎస్ విల్ టేక్ కేర్ ఆఫ్ ఆల్ యువర్ హార్డ్వేర్ రిసోర్సెస్. దానికి ఎంత సర్వర్ కావాలి, ఎంత ఇది కావాలి, ఎంత రిసోర్సెస్ అయినా ఇచ్చేస్తుంది. ఓకే. సో అక్కడ మేనేజ్ చేయడం ఎలా, మనం ఓన్గా ఎలా మేనేజ్ చేసాం, ట్రై చేసాము. ఒకటి ఫార్గేట్ ఎలా ట్రై చేసాం. ఓకే. సో ఇంకొకటి ఏంటి అంటే ఈసీఎస్ అంటే ఈసీఎస్ కంటైనర్, ఇప్పుడు ఎలాస్టిక్ కంటైనర్ సర్వీస్ ఈజ్ ఓన్లీ అప్లికబుల్ విత్ ఇన్ ఏడబ్ల్యూఎస్. ఫర్ ఎగ్జాంపుల్ మీరు ఇప్పుడు వేరే క్లౌడ్లో వర్క్ చేస్తున్నారు, గూగుల్ క్లౌడ్ ప్లాట్ఫామ్ ఉంది, సిమిలర్లీ అజూర్, అజూర్ ఉంది. సో ఇప్పుడు ఫర్ ఎగ్జాంపుల్ మీ కంపెనీ ఇప్పుడు గూగుల్ క్లౌడ్ ప్లాట్ఫామ్లో వర్క్ చేస్తుంది అనుకో, అక్కడ మీకు ఈసీఎస్ ఉండదు కదా. సో ఈసీఎస్ యూ వోంట్ గెట్, ప్యారలీ వాట్ వి సే, మన ఫార్గెట్ సర్వీస్ ఉండదు. సో దేర్ షుడ్ బి, ఇప్పుడు దేర్ షుడ్ బి వన్ కామన్ టూల్ విచ్ కెన్ బి యూస్డ్ ఆన్ ఆర్ ఎనీ టైప్ ఆఫ్ ప్లాట్ఫామ్. సో అప్పుడు ఏంటి అంటే దెన్ దిస్ కుబర్నెటిస్ విల్ కమ్ ఇన్ టు పిక్చర్. సో ఈ కుబర్నెటిస్ ఏంటి అంటే ఇట్ ఈస్ అన్ ఓపెన్ సోర్స్ సాఫ్ట్వేర్. సో ఈ ఓపెన్ సోర్స్ సాఫ్ట్వేర్ విచ్ ఈస్ అవైలబుల్ త్రూ ఆల్ ద ప్లాట్ఫామ్స్. ఇప్పుడు ఏంటి అంటే ఈసీఎస్ నేర్చుకున్నారు మీరు. సో ఈసీఎస్ నేర్చుకుంటే ఈసీఎస్ ఈజ్ ఓన్లీ అప్లికేబుల్ ఫర్ ఏడబ్ల్యూఎస్. అదే మీరు ఒక ప్రాజెక్ట్ ఇప్పుడు గూగుల్ క్లౌడ్లో చేస్తున్నారు, అక్కడ ఈసీఎస్ ఉండదు మీకు. సో అప్పుడు ఏం చేస్తారు, బట్ ఏంటి అంటే కాన్సెప్ట్ తెలుసు మీకు, కంటైనర్స్ ఎలా రన్ అవుతాయి, క్లస్టర్ ఏముంటుంది, కాన్సెప్ట్ అంతా తెలుసు. బట్ ఏంటి అంటే ఎగ్జిక్యూషన్ చేయలేరు, ఈసీఎస్ అనే టూల్ ఉండదు అక్కడ. సో ఇప్పుడు కామన్గా ఈ అన్ని ప్లాట్ఫామ్స్కి ఏదైనా ఒక కామన్ టూల్ ఉండాలి మన దగ్గర. సో కామన్ టూల్ ఏంటి అంటే దెర్ ఆర్, ఇప్పుడు ఏమంటారు అంటే వీటిని ఆర్కెస్ట్రేషన్ టూల్స్ అంటారు అన్నమాట. సో ఆర్కెస్ట్రేషన్ టూల్స్ అని అంటాం మనం దీన్ని. సో సేమ్ ఇప్పుడు మనకు తెలిసింది ఏంటి, ఈసీఎస్ ఒకటి చూసాము, నెక్స్ట్ ఏం చూసాము, ఫార్గేట్ ఒకటి చూసాము, రైట్. సో దీస్ ఆర్ ఆల్ లిమిటెడ్ టు ఏడబ్ల్యూఎస్ ఓన్లీ. ఐ హోప్ యూ గైస్ ఆర్ గెట్టింగ్ ద స్క్రీన్ నా, స్క్రీన్ వస్తుంది కదా.
Yes, sir.
ఓకే.
Yes, yes.
సో దీస్ ఆర్ లిమిటెడ్ టు ఏడబ్ల్యూఎస్. ఫర్ ఎగ్జాంపుల్ ఇప్పుడు మనము గూగుల్లో ఉన్నాం, ఆర్ ఎల్స్ అజూర్లో ఉన్నాం, ఆర్ ఎల్స్ ఎనీ అదర్ ప్లాట్ఫామ్, ఎనీ అదర్ క్లౌడ్ ప్లాట్ఫామ్ ఉంది. సో ఇక్కడ మనకు చేయాలి అంటే సో వీ హ్యావ్ టు హ్యావ్ దిస్ ఆర్కెస్ట్రేషన్ టూల్. సో ఇక్కడ మనకు ఆర్కెస్ట్రేషన్ టూల్స్ ఏంటి, సో ఇక్కడ వచ్చేసి దెన్ విల్ హ్యావ్ సమ్ అదర్ టూల్స్ ఇన్ ద మార్కెట్. ఓకే. సో ఇలాంటి టూల్స్లో ఏమొస్తుందంటే వన్ ఇస్ డాకర్ స్వామ్ అని వస్తుంది. సో దిస్ ఇస్ ఆల్సో వన్ ఆర్కెస్ట్రేషన్ టూల్. తర్వాత ఏమొస్తుంది, వీఆర్ టెలింగ్ దట్ కూబర్నెటిస్ అని అంటున్నాం. సో ఇది వస్తుంది. దీని షార్ట్ కట్గా ఏమంటారంటే A8S అని అంటారు అనమాట. సో షార్ట్ కట్. సో 8 is nothing but the number of alphabets in between. So 1, 2, 3, 4, 5, 6, 7, 8. సో ఈ 8 ఆల్ఫాబెట్స్ కలిపి 8 అనే నంబర్ని ఇచ్చేస్తారు. ఓకే. సో దిస్ ఇస్ కుబర్నెటిస్. నెక్స్ట్ మీసోస్ అని ఒక సాఫ్ట్వేర్ ఉంటుంది. సో దెర్ ఆర్ మల్టిపుల్ సాఫ్ట్వేర్స్ విచ్ విల్ డూ దిస్ ఆర్కెస్ట్రేషన్ జాబ్ ఫర్ అస్. ఓకే. సో మనం ఇది ఇప్పుడు వీఆర్ ఫెమిలియర్ విత్ దిస్ ఏడబ్ల్యూఎస్. నౌ విల్ ట్రై టు ఎక్స్ప్లోర్ Kubernetes. So Kubernetes ఎందుకు చేయాలి అంటే దిస్ ఈజ్ యాక్చువల్లీ there are so many advantages. సో అదేంటి అంటే వన్ బై వన్ విల్ గో త్రూ మనకు క్లియర్గా అర్థమవుతుంది. సో యూ కెన్ ఆల్సో లెర్న్ డాకర్ స్వామ్ విచ్ ఇస్ ఆల్సో దర్. బట్ ద థింగ్ ఇస్ మార్కెట్లో ఏంటి అంటే అరౌండ్ ఒక 57 to 60% ఆఫ్ ద పీపుల్ ఆర్ యూజింగ్ Kubernetes only. So that is the reason we'll try to understand this tool. Okay. So we'll try to understand. So first ఇప్పుడు మనం ఇప్పుడు we are saying that okay we are needing some orchestration tool. So to manage our containers. So what Docker is doing, Docker is creating one images. It is just providing you a platform for engine for your images and containers. But the thing is orchestration tools are different. So అది మనం ఇప్పుడు ప్రాక్టికల్ గా మనం if we try to understand better, then you will be understanding in a better way. Okay. So, and please understand that to enter into these topics, first you need to have the basic knowledge about images and containers, Docker Hub. ఈ knowledge untene, then you can proceed into this. So, only this need to be learned after practicing Docker. Okay. So, I think we have already completed working on Docker. We have created images, we have deployed images, we have worked on containers. Right, docker commands kuda koncham manaku idea undi, right? So now we are eligible to learn these tools. Okay. So basically simple ga ardham chesukovalante when you see so docker ఒకసారి logo చూడండి. Okay. So as you can see you are seeing one ship. సో ఈ షిప్ లో మనం ఏం చేస్తున్నాం, వీఆర్ ప్యాకింగ్ అవర్ కంటైనర్స్. యాజ్ యూ కెన్ సీ 1 2 3. ఇప్పుడు ఏంటంటే ఒక ప్రాజెక్ట్ ని వీఆర్ స్ప్లిట్టింగ్ ఇన్ టు మల్టిపుల్ ప్యాకేజెస్ అండ్ వీఆర్ పుట్టింగ్ ఇన్సైడ్ వన్ షిప్, రైట్? సో ఈ షిప్ లోపల వీఆర్ హ్యావింగ్ దిస్ కంటైనర్స్. సో ఇప్పుడు ప్యాకింగ్ వరకు బాగానే ఉంది, రైట్? సో దీస్ ఆర్ ఆల్ డిఫరెంట్ ప్యాకేజెస్ ఆఫ్ ప్రాజెక్ట్స్ విచ్ కెన్ బి పుట్ ఇన్సైడ్ వన్ డాకర్. సో డాకర్ జాబ్ వరకు అంతే, ఒక ప్రాజెక్ట్ తీసుకొని ఇట్ ఈస్ క్రియేటింగ్ మల్టిపుల్ ఇమేజెస్ అండ్ దే పుట్టింగ్ ఇన్సైడ్ వన్ కంటైనర్స్. ఓకే, నౌ దిస్ ఈస్ అప్లికబుల్ ఫర్ ఓన్లీ సింపుల్ టాస్క్. ఒక ప్రాజెక్ట్ కి మాత్రమే వర్క్ అవుతుంది, రైట్? ఒక ప్రాజెక్ట్ ని నార్మల్ గా ఇట్ విల్ డివైడ్ అండ్ పుట్ ఇట్ ఇన్ టు మల్టిపుల్ ప్లేసెస్, రైట్? ఫర్ ఎగ్జాంపుల్ ఇప్పుడు ఒక ఫేస్బుక్ ప్రాజెక్ట్ ఉంది అనుకోండి. ఫేస్బుక్ ప్రాజెక్ట్ ఇట్ డజంట్ మీన్ దట్ ఇట్ ఈస్ ఓన్లీ వర్కింగ్ ఫ్రమ్ వన్ రీజన్. సో యూ విల్ బి నీడింగ్ సో మెనీ ప్యాకేజెస్ according to the region. So that there will be some enormous number of data. So అక్కడ ఏమవుతుంది, ఓన్లీ వన్ షిప్ విల్ నాట్ బి సఫిషియంట్. సో యూ నీడ్ టు హ్యాండిల్ మల్టిపుల్ షిప్స్ ఎట్ ఎ సేమ్ టైం, రైట్? ఇక్కడ ఏంటి అంటే ఒక ప్రాజెక్ట్ వన్ షిప్, జస్ట్ ఫర్ యువర్ అండర్స్టాండింగ్ ఐమ్ టెలింగ్ హియర్ ఐఎమ్ టేకింగ్ వన్ షిప్, ఐఎమ్ క్యారింగ్ 1 or 2 projects, right? Similarly now I have 100 ships. So how to control this 100 ships? So that is the place where Kubernetes will come into picture. సో అందుకే ఇప్పుడు చూడండి Kubernetes లోగో చూడండి ఒకసారి. So as you can see in this Kubernetes logo, you can see just one wheel type. So this wheel is nothing but the steering to the ship. We can say steering kada. So that is the reason they have made in this way. So ఇప్పుడు ఈ షిప్ ఉంది, షిప్ ని మనం ప్యాకేజ్ చేసి పెట్టాం, రైట్? సో ఈ షిప్ ఉంది, బట్ ద థింగ్ ఈస్ ఇట్ నీడ్ టు రన్, రైట్? సో ఇట్ నీడ్ టు రన్, ఇట్ నీడ్ టు టేక్ అప్ పేస్, ఇట్ నీడ్ టు స్లో డౌన్, ఇట్ నీడ్ టు స్టాప్. సో ఈ యాక్షన్స్ అన్ని డాకర్ కెనాట్ డూ ఇట్ బై ఇట్ సెల్ఫ్, రైట్? సో దట్ ఈస్ ద రీజన్ వెన్ దెన్ విల్ బి needing some tools to handle these containers. So that is the case we will come into start using this orchestration tools. So అప్పుడు we'll come to use orchestration tools. So so one of the orchestration tool which we use is Kubernetes, or else you can also use Docker Swarm, or else you can use also Mesos. There are so many other softwares also available in the market. Okay, so this is just for your understanding and introduction purpose, just I have told you. Okay. So first thing is to again to get into these things. First, you need to understand what was the uh, previously how the task was done and how this Kubernetes is making our job easy. సో దాన్ని అర్థం చేసుకోవాలంటే ఫస్ట్ థింగ్ ఈజ్ యూ నీడ్ టు అండర్స్టాండ్ monolithic architecture. So previously how they used to handle our projects. Okay, so అది చూద్దాం ఫస్ట్. ఓకే, సో ఇక్కడ చూడండి. సో monolithic architecture I think we'll see. Okay. This I think okay, we'll see only first one simple monolithic architecture. Right. So I think this is one of the best example we can take for monolithic architecture. So, so you can just try to understand from either side. So this is from for user side, and this is the backend, right? So user side, what the person will do, the user will use a browser, and it will he will play you will place one URL. For example, you take facebook.com. Okay, so client browser look just he will open facebook.com and he will send one request. So in the background, what happens is, as you here you can see, only one single instance will be there. So in this single instance, all your necessary database will be stored. So in this single server will be handling all your jobs. So this it is the responsibility of this single server to maintain the inventory of all your products, and to maintain your shopping cart, and to maintain your payment. All right, so as you can see, all your information will be stored in one single instance. And for your very easy understanding, I can tell you this as your maybe your university results. So all your university results will be stored in one single instance, right? So the user will place the request, and it will this single server will be responsible for providing the response to all the client requests, right? So this was the previously how the architecture was. So only one single server which will be handling all your jobs which are requested by the user, right? So now, this we have came into this type of architecture now, right? So this is microservice architecture. So right now what we are working on containers and everything. So that will be coming under this microservice architecture. Okay. So for your simple understanding, I'll tell you one. I think this will not make you understand. I'll tell you one. We'll see for another picture. So API gateway architecture. Okay. We'll see. Hmm. This is half. This is also half. This is also half. Right. So just you now you what you can do is just try to understand this architecture now. Okay. So previously we have checked this monolithic architecture, and right now we are try to understand this microservices architecture. Okay. So here you can see what is happening. So there are two sections. One is the client section and one is the server section, right? So first, what is happening? So previously, okay, we'll see that we can compare both at once. Then I think that will make better sense. Okay, here it is, right? Okay, so here you can see the browser is directly able to communicate with your instance directly. So here what happens with our microservices is, so directly your database will not be able to access your database will not be accessible directly. So first using maybe whatever the medium with which user might be using, whether it is a website or mobile application or web application or whatever it is. So first the request will be taken by API gateway. So here all the logic of your website will be handled through your API gateway. For example, the user is asking to take the catalog. So you will put a request to this API gateway. Now this API gateway will take the decision and split and try to connect to that accordingly, right? So for example, if this person is asking for catalog, so API gateway will redirect the request to catalog, right? So only this will be accessed, and inside this catalog the data will be fetched and will be given back to the user. So similarly, in the simple I think we have discussed the other time. So I think we have discussed about this Facebook in the previous classes also. So Facebook will have so many different databases. So for example, it will maintain users database separately, it will maintain groups database separately, it will maintain images database separately, and what we say marketplace database separately, ads database separately. But at the end of the time, all this will be showed on single website, right? So how they are able to manage these things is they are trying to split the traffic and split the database according to these sections. So here catalog they are maintaining separately. I think this is applicable for Flipkart. So catalog they are maintaining separately, shopping cart they are maintaining separately, discount they are maintaining separately, ordering system they are maintaining separately, such that multiple people can work on this project at the same time. So ordering department developers they'll work separately, so these discount department they work separately, shopping cart work separately, catalog separately, right? So that time what happens is so all people are not dependent on one single database. So what happens with one single database if you are keeping? So if you want to change or update anything, so what you need to do is you need to stop the complete server for single time and you need to put the update. For example, if you have developed something in the ordering section, okay, so ordering section or else you will go for the discount. So what happens is they have started one big billion day, okay, so big billion day is happening around 12 a.m, right? So at 12 a.m in the morning some changes they have done. So from the particular days they are giving some 20% discount on everything. For example, let us assume one scenario. So 20% discount will be given. So what you need to do, you need to make changes in the discount section such that your ordering, shopping cart, catalog, everything will remain the same. You need not disturb anything. So that time what you will do, you'll just work on this discount section and you will update only this particular space, only discount section will be updated such that there will be no disturbance for the shopping cart, catalog or ordering. So imagine the same scenario in monolithic architecture. So in what happens is, as you know, everything, all your databases are sitting on one single instance, so only one single database is there. So even if you want to change the discount, you need to change the complete database, right? So that will be a difficult problem. The whole website will be coming under this halt time. So here the waiting period will be very very less. Why? Because we are not disturbing any of the other sections. So except this particular section we are not disturbing any of this. So this will reduce your time and your chances of failure also. Okay, so this is called as this microservices concept. So this became much more popular with the introduction of containers. So here what people are doing is simply they are building containers, and for example this catalog is there. So inside this catalog they will deploy one Docker engine, and under this Docker engine they will be deploying your containers. I think we are very familiar with this Docker architecture. So Docker engine, I think this architecture, I think you are very familiar. So this will be your so this will be your Docker engine will be installed, and under this Docker engine your all containers will be running. So one separate Docker engine for catalog, separate Docker engine for shopping cart, separate Docker engine for discount, separate Docker engine for ordering, right? So in this way, in this only your containers you will try to add the containers, you will try to delete the containers, and you'll be handling only your container section. And more importantly, the much more bigger responsibility of this microservices is this API gateway. Okay, so this we can say as the mastermind which is regulating all these actions, right? So this person is responsible for everything. Okay, so first the user will come, then put the request here. So according to this person will take the decision of splitting the request. In the similar way, even the developers who are developing all these actions will be passing through this gateway only. Okay, so even the developers will use the API gateway, and this clients who are using the regular users, they'll also be using this same API gateway, right? So the main thing is the master who is handling all this need to be very intelligent. So that is the place where we will be using this. This is the place where it started one new revolution called as, what we say it as, master slave. Okay, master slave concept has been started. So here I can, you can see the simple here you can understand who is the master. So this master is this API gateway, and all these people are slaves. So the master will ask for the data to the right person, and these slaves will also provide the data to the master, and again this master will pass the data to the user. So that is why this master and slave, or what we say, we'll say also nodes we are saying, or minions we are saying. And there are so many names given to this type of architecture. Some people will say master and nodes architecture, or master or minions architecture. So this became very popular after the introduction of this API gateways. Okay, so this is just to, because you need to understand while we are entering into this thing. So that is the reason I'm just trying to give you more number of examples. So now now you need to now you can, I think, understand now. So we are very familiar with the Docker. So with Docker, what we have done using Docker, first thing is we have created one image, then we have given it to Docker, and then we have created one container, right? So this was working very well, right? So now I am saying orchestration tool. Sir, why we need orchestration tool? Just Docker engine was sufficient. So in this Docker engine, so we have seen this, right? So in this Docker engine, what we have done, oh, sorry, this is not correct. Okay, so we have taken one server, we have installed one operating system, and we have installed Docker engine. As you can see, app 1, app 2, app 3. These are all working fine, right? So Docker engine is able to run our containers properly. Then again, why we need of this orchestration tools, right? You got my point? So Docker is doing our job very well. So we have created one image, we have created containers, and we are running on this instances. So here you can see one Docker engine is able to handle one, two, three, maybe some 10, 10 apps. It is able to handle properly, right? So, but still you are able to, now you are asking for orchestration tool to manage your containers. So Docker engine is already managing your containers, right? But still you are asking for orchestration tool. So I'll tell you one simple scenario. So for example, one container I'm creating, okay? So one container I'm creating, just for your assumption I'll say, so one container it will cost you 500 rupees, okay? So similarly, I'll say, for example, if I, for example, we'll take this one. We'll take example of IPL only, or IPL, or Netflix, or some Prime. We'll take example. Okay. So one container, for example, I'll say one container can handle around 10 people at the same time. Okay. So this handling this 10 people, they are charging us rupees 500 rupees for one container. So now I'll say we'll take 10 containers. So now the charge will be rupees 5,000. So now immediately I'll say 100 containers. So it will become 50,000. Now I'll say 1,000 containers. So now it will come become 5 lakhs. Sorry, maybe 50. Sorry, 5,000, 50,000, maybe 5 lakhs. Yes, right. So in this way we are able to create. So here you can see Docker engine will only be able to create containers. So hardly it is only Docker engine will be only helpful to run your containers, that's it. So here you can see Docker engine, what it is doing, it is able to run the container, that's it. So only for running the container we might be using Docker engine. But so imagine this scenario. You need to instantly create 1,000 containers. So we need to create 1,000 containers. So it is a Docker engine will only just be used to run your container, not for create, not for handling these containers. So it's a single time. As you know, this is time constraint. So for example, these are the charges for 1 hour, I'll say, just for your for 1 hour charges. Okay, for running for one container for 1 hour, they are charging 500 rupees. 10 containers they are charging 50,000 rupees. Okay, for example, I want to create, for example, this IPL is running. Okay, I want to create 1,000 containers in the 18th or 19th or 20th over, right? So as you can see, after 20th over, so automatically the 1 crore people who are viewing our match will be reduced to almost half, less than half. Maybe I can say less than half. For example, if you are handling your servers by 5,000 containers are you using, okay? So you should immediately decrease this number of containers to what we say, for example, 1,000, right? So 4,000 containers you have to remove instantly. As if you are not removing your 4,000 containers at the same time, what will happen? So for every hour, almost 5 lakhs rupees, right? 5 lakhs into 5,000. 5,000 means it will become 4 lakhs loss you will get. You'll be getting 4 lakhs loss if you're continuing to use that. So what should happen is this should happen within milliseconds or within, I'll say, minutes. So within minutes of time, you need to reduce this 5,000 containers to 1,000 containers. So for the in that case, this Docker engine will not be able to do the job for you. So it will just able to give Docker engine will give you a runtime where you can run your containers. That's it. So this adding for 1,000 containers, removing these 5,000 containers, or adding this containers at the some it milli times, a milliseconds time, it is not. This job cannot be taken by this Docker engine. So Docker engine is just a runtime provider for containers. Okay. So orchestration tools are required to handle containers. So you might be asking, sir, what this orchestration can do? We can manage our containers. So what we can do first, I'll tell you what are all the advantages. Okay. So first thing is what you can do is auto create containers. This is one of the job which is done by this orchestration tool. Similarly, auto delete containers. Third one, we can say auto scaling containers. So these all activities we can do using this orchestration tools. So in other terms, in very easy terms, if you are unable to understand this orchestration, what we can simply, the other name is container management tools, and kuda we can tell this. So container management tool tools and kuda we can say. So if someone is asking orchestration tool or management tool, the other name for this orchestration tool, we can also say that container management tools. So now might be asking, sir, what are these container management tools we are available in the market? For example, Google is providing us this tool. So now we are learning about Kubernetes, right? So Kubernetes is provided by Google. So what they are telling is they are providing in the name of GKS, whereas uh, AWS is also providing the same tool with the name EKS, and it is also available on Azure with the name of, I don't remember this. Maybe Azure Kubernetes tool. Maybe we'll assume the same thing. EKS only we'll say. Okay. So as you can see, we are trying to learn Kubernetes. Why? Because it is available across all the platforms. Okay. So we'll be exploring. Right now we are working on AWS. So we'll be working on this EKS tool. Okay. And one more important thing I forgot to mention, this Kubernetes will work on any container. For example, we are using Docker, right? So for container, Docker is creating containers for us, right? So similarly, Kubernetes is not only limited to this Docker. So there are some other tools which can also use, which can also create and manage containers. So Docker is not the only software which can create containers. So there are also some other tools in the market which will be creating containers. So what the advantage of using this Kubernetes is, Kubernetes will also help to manage your containers not only for the Docker and also for other container softwares also. That means Kubernetes will help not only with Docker and any other container tools also, it will help you out. Okay. So what all we can do with this? This is create containers, auto delete containers, auto scaling containers, and some more I will add. So we'll say automate we have added, and automate deployment. So it can also do this deployment job also. Okay. So scaling job also it will be doing, and also fifth one is it will do the load balancing also for you. Okay. So these are all one of the tasks which can be done using our Kubernetes. Okay. So sixth one, what you can do is schedule, run, and manage containers. So that we can do, and this Kubernetes can be installed on our own physical servers also. So that means you can install this Kubernetes software on your physical server. You can install this Kubernetes software on the cloud. So in all the places it can be installed. So it can be installed virtual servers, physical servers, and cloud machines also. That means what you can do is, for example, we are all working on this, what we say, our instances, right? So as you know that we are working on this master slave category. So for example, we can you can create one master, and you can add two slaves. So and also you connect all this together. For example, I will say master slave architecture. Okay. So here you can say, for example, okay, just try to understand. So we are creating one, two, three, four. Maybe I can say, or else we can just consider this category. One, two, three. So one is the master, and slave one, slave two are two others. So what we can do is we can create three instances, and we can create our master, and we can also create our slave. So instead of depending on all these services which are provided by AWS, we can create master by installing Kubernetes software. Similarly, we can create two slaves by installing Kubernetes software. So this can also be done manually. Okay, so that manual job also can be done using this Kubernetes software. Okay, because it is an open source software, you can just download and you can use it. Okay, so if you want to know something about this Kubernetes, there is some history available. So first, it is developed by Google. So Google is the one who was developed this software. Okay, so Google is the one who have introduced this Kubernetes as the software, and also which was an internal software for them. Okay, and in the initial days it used to be called with the named it as Borg. So first, previously, when Google has developed it, it has given the name as Borg. Okay, so why they have done is, they in the initial days they used to deploy and manage thousands of Google applications and services. For that purpose, they have used it, because Google is becoming very popular in those days, and for them they used to handle so many applications at the same time. So for that reason, Google has developed this software for themselves, and they called it as Borg. Okay, so in 2014, so they have introduced Kubernetes as open source. So that means they have given the software to everybody in the year 2014. So this time it was developed in two languages. One is Golang. Okay, Golang language. So maybe sometimes they will you ask you in this interviews. Okay, so after this, what they have done is, they have donated this software to CNCF. Okay, so if you are asking CNCF is nothing but Cloud Native Computing Foundation. Okay, so this is one government organization. For them, they have donated this. So Cloud Native Computing Foundation. For these people, they have donated the software. So first, it was just launched in the name of Kubernetes in the year 2014. It was developed in Golang language, and it was donated to Cloud CNCF. Okay, so for this, we'll be needing two tools. So what are the tools, softwares which we use for uh, uh, learning or implementing Kubernetes is? So one is Minikube is the software which we'll be using, and the second one is Cube A Cube ADM. Okay, so these two softwares we'll be using for working on Kubernetes. Okay. So for this you might be asking, sir, we need to write program for this Kubernetes. Yes, we need to, we'll be doing Kubernetes Kubernetes scripting we will be doing. So for that you might, so for that we'll be using one manifest file we'll be writing. So you might be asking, sir, how to write this manifest file. So for this we'll be writing two languages. So JSON, by using this JSON you can write the manifest, or by using YAML we can write the manifest. So similarly, like while creating our Docker images, we are writing commands, right? So similarly, for the execution of this Kubernetes, we'll be writing manifest files. Okay. So these manifest files can be written in JSON or YAML language. Okay. Right. So we'll explore now and we'll try to understand exactly how this Kubernetes will be working. So we'll explore on this Kubernetes architecture. Okay. So this we'll try to understand now. Okay. So I think we'll take some break. So maybe now it is almost 9. So we'll come back at 9:10, and we'll resume working on this Kubernetes architecture. Okay. So we'll meet at 9:10 a.m. Okay. Guys, are you there?
Yes, sir.
Okay, shall I start? Okay, so I think now we have to start with this architecture. Okay, so first to understand this Kubernetes architecture. So first we need to understand about this client server, or we can say master slave architecture. Okay, so I think that is what we have tried to understand. So there will be one master and one will be the slave. So this we have tried to understand in the previous class. So there will be one master, so the other will be slaves. Okay, so in the simple normal language we'll say master slave. Okay, so there will be one master, and the slaves will be connected to it. So the Kubernetes also will function in the same manner. Okay, so I think if you can correlate, ECS was we have already got exposure into ECS, right? So ECS was also master slave architecture only. Okay, so I think if you have this ECS nodes, you can just compare. Right. So here you can see, so we are creating cluster, right? So under this clusters, or our we are connecting our instances. Okay, so this we can call it as master, and this we can call it as slave, right? So as you know that ECS is completely provided by AWS, so it is installing all your necessary software which are required for your master. As you can see, we have never installed any specific software, or any Docker software, or any master software, or any slave software inside our ECS system. So this Amazon will provide you all the relevant software which is working for the system. So but in Kubernetes we have to do the manual installation. Okay, so we have to install this master software, so we have to install this slave software. Okay, so what you can understand in the simple way, when you are learning this Kubernetes architecture, you can say that it is one master slave architecture. Okay, or else mostly people will call it as master and nodes. Okay, so this is a principle which we follow in our Kubernetes. Okay, so there will be three types of clusters. Okay, in Kubernetes. Okay, so first one is one master, one node. Okay, so this is one type of cluster, and one is second one is one master, multiple nodes. So other one is multiple masters, multiple nodes. Okay, so simply for your understanding, I can just give you one small picture. So I'll say paint, I'll take. Okay, so the architecture I just tried, just I'll give you in a brief way. So one is one will be the master, so one will be the node. So this will be direct the master to the node communication. Okay, this is one type. So whereas one master and multiple nodes. So this is come under, this will come under one master and multiple nodes. Okay, so is there, here you can see it is the same again. One master will be there. Again, these three nodes will be there. So one is, this is the second one. And again, I am saying multiple masters and multiple nodes. So even we can also manage this way. So you can use multiple masters and also multiple nodes. So in these three architectures, our Kubernetes can be implemented. Okay. So this is how you will be implementing Kubernetes. One is master to master, one master, multiple nodes, multiple masters, multiple nodes. So in these three levels, we can execute our Kubernetes. Okay. So getting into this, now we'll try to understand into much deeper level, like what, how master will work. Similarly, what this, how this node will be working. Okay. So for the try, we'll try to go deeper into this. So this is very, very important. In most of the interviews, the questions will be based on this architecture only. If you are able to present this architecture to your interviewer, so almost you can convince him to the job. So we'll see how this will be executed. So this will contain everything, like we can say whatever Kubernetes is there. So this architecture will carry out everything. So we have understood one thing very clearly. So in the previous classes, so here what happens is, uh, our the user, what he will do, he will run a request to one, for example Chrome, he will take, he will use one browser. Okay, so then what he will do, he will send one API. Okay, so request he will be paying. So this will be taken by our API gateway, right? So this API request will be taken by API gateway. So this, what this API gateway will do, it will split the request and it will take the decision to the correct person. So these are all different functions. For example, this is, as we have already seen, this is one catalog, this is one order section, one this is a payment section, and one this is user section. So here the database will be connected separately. So this is nothing but DB. So the user will send request through a browser through API. That API request will be given to API gateway. That API gateway will take the correct decision. It will send the request to the proper person, and it will fetch the data, and it will take back the data, and it will return back to the user. So here you can see we are saying that API gateway is our master, right? So our master is taking all the decisions which are relevant to the, which are according to the request coming from the user, right? So now we'll try to understand how exactly this master will be working, right? So it is how this API gateway will be working, right? So coming back, so I think we have several pictures in the market which will make you understand. So I think okay, we'll see some pictures. Okay, right. So I think this should help you in understanding our Kubernetes architecture. Okay, so this is nothing but the left section which you are seeing here. This is your master. Okay, so the right section which you are seeing, these are all your slaves. We can also call it as nodes, or we can also call them as minions. Okay, so the left section, this person is called Kubernetes master, and these are all your server slaves. We can say one, two, three slaves, or else we can say Kubernetes minions. So this is master and minions architecture. So this is the master, this is the minion. Okay, so as we have found out that, so this is the cloud, or we can say the user what will do, he will place one request through browser. So I think okay, there is no paint here. Okay, this is just for editing purpose only. Okay, so what happens, the user will come from here. So user we can say, so user what he will do, he will take one browser. Okay, through browser he will be sending one request. So as you know, first the request will be taken by the master. So master only will connect to the appropriate minion. So first this request will come to API server. Okay, so this API server will need to take decision, and it will need to send the request to any of the minion, whichever is correct. To according to that, it will send the request. From here, it will take the response from any of the server. It will take back, and it will give it back to the user. Okay, so now you need to understand the master, how this master will take the decision first. Okay, so first we'll understand how this master and the slave will be created. Okay, so what will happen first is, so here first you can start with ETCD. So ETCD is nothing but a small database. So it will hold all the information which is related to our nodes. So it will have all the information like how many nodes are there, how many are in working condition, how many are in crashed condition. Okay, how many how much hardware resource is having in this particular node. That means we can say a small database with all the information regarding to the your nodes will be stored at this place. Okay, so this will be updated always. Okay, so what happens is, here we can say almost this cube control manager or this cloud controller manager, both are same only. So it will try to manage all your nodes. I'll say instead of minions I will say nodes. Okay, so one node, node 1, node 2, and node 3. So I have three nodes here, 1, 2, 3. So all the information regarding to the nodes will be stored in ETCD. Now you can say, sir, what is the responsibility of this Cube Control Manager? So Cube Control Manager will try to fulfill the information, right? For example, we have created three nodes, right? So here the information will be stored in the etcd, right? Three nodes are created. Okay, so now cube control manager will be always running in the background. Okay, it will run in the background, it will check and fulfill this needs. For example, here it has said that nodes equal to 3. It will try to maintain 3 nodes always. Okay, for example, in the running state, for example, what happens is node number 3 will get failed. Okay, or else we can say crashed. So what will happen, as you know, this cube control manager, they will be running in the background, right? So it will get the information first. Okay, so this queue control manager will get the information first that node number 3 got crashed. So what this queue control manager will do is it will go to this etcd and it will check for the information. So it will take the information from the etcd, so it will ask how many nodes should be there. So then etcd will tell that, as you already know, so we need to have 3 nodes, right? But and then it will go and cross check with these nodes, but actually there are only 2 nodes, so one node got crashed. Okay, so it will be found by the cube control manager. So this is the person who will be running in the background. He will sit and he will watch. Okay, what he will do, he need to maintain the etcd request. Like for example, if here if it is 3, then here also the node should be 3. So now it has found out that it has only 2 nodes, right? So 2 nodes is not the correct number, so we need 3 nodes. So what this cube control manager will do, he will inform cube scheduler. Okay, so what this cube scheduler will now do is it will create one new node. Okay, so all this creating or deleting your nodes will be performed by cube scheduler. Okay, so whereas cube controller will manage the number of nodes, it will be like a background service. It will sit in the background and it will observe your nodes. So 1 2 3, it will observe the nodes. If there is any change in these nodes, it will go and check the database which is there in the etcd. So here we will be declaring our needs. So it will check with the database values, and if it finds any difference, immediately what it will do, it will inform the cube scheduler. It will inform the cube scheduler to take the action. For example, if it is having one less node, so it will ask cube scheduler will create one extra node. Similarly, there is you need to delete one node, so the cube scheduler will delete the node. Okay, so this is the brain of the master. Okay, so the brain of the master will be comprising of three, maybe I'll say four important components. One is cube controller or cloud controller, both are almost the same only. So one is controller you will have, one is etcd will have, one is cube scheduler will have, and very very importantly, Cube API server. So now you might be able to understand. For example, these four components are there. One is your nodes, one is your Cube controller manager, and etcd and Cube scheduler. So as you can see, everything is connected to this API server. Okay, so all the communication, irrespective even it is coming from the user or all the internal communication, it will happen only through this API. Okay, so we can also call it as API gateway also. So here we can say this as gateway also. I'll say or else API gateway. So it will also help you for the communication from the outsider and also for the communication from the inside. So here you can see, for example, I told that Cube Manager will send the signal to Cube Scheduler. So as you can see, Cube Controller Manager is not directly communicating with the Cube Scheduler. So what it will do first, it will go and inform the API gateway. Okay, so this Kube API server. So this Kube API server will send the request to the Kube scheduler. Okay, so what now this Kube scheduler will do? It need to create one node. Okay, for example, node number 3 it need to create. So this Kube scheduler will create the node number 3 only after sending the request to Kube's API server. Through this, it will go and create the new server. Okay, so again after creating the server, so this information will be passed to the API gateway. So again this API gateway will update the values in the ETCD and it will tell three servers are running. So that means this is accomplishing. So three number of nodes are working. So this will again in the background this queue control manager will check. So if this three number of servers are running or not. So one, two, three are running, no problem. For some time, I'll say cube number of three will get crashed. Okay, so at that time, what happens? This information will be given to the this queue number three got node number three got crashed. So this information will be given to the API gateway. This API gateway in the background, this queue controller manager will be prompted. So API gateway will tell. So there is some disturbance in the node. So again, this API gateway will inform the manager. So now what this manager will do? It need to communicate with etcd and it need to find out what are all the actual values. Okay, so that is the reason again this kube control manager will give the request to API gateway and it will try to communicate with etcd. So here it has found out that what happens, only three servers we need, but actual running condition is two, right? It has found out the error. Who? This cube control manager. So again this cube control manager, what it will do, it will go and inform API gateway. So what this API gateway will do, it will send the signal to cube scheduler, there is one missing node, so create one new node. So what this cube scheduler will do, this cube scheduler will create one new node through API gateway. So here also the medium will be API gateway only. So here the API gateway, through this API gateway it will go and create one new node. Okay, so this new node again it will be updated. So this information will be taken by API gateway and it will be updated in the ETCD. Okay, so as you can see, ETCD, it is a small database which will be holding all your information related to your nodes, or your running condition and everything. Okay. Similarly, Kube Control Manager will make sure that your nodes are working properly. Okay, so it will always try to check your nodes, all your nodes are working correctly or not. Okay, so if at all it is not working, it will check with the databases and it will, if you find any differences, it will send the signal to cube scheduler. So here what cube scheduler will do, it will create or delete any nodes which whenever it is necessary. Okay, as you can see, no one is taking any decision except API gateway. So everybody got connected with each other through this API gateway. So that is what the all the decisions will be taken from your master nodes. Okay, so this is very very important. So this is about your master node. So how the master node will be working, right? So now you will try to understand the nodes. Okay, worker node or minions, whichever we can say. Okay, so one thing and also you need to remember that even your users or admin or your developers, you can say developers, admins or users, testers. So everybody will be communicating with the master node only. So all these people, so if you want to handle any part of your servers, you need to communicate with the master node only. So through master node only, you will be able to control your nodes. And similarly, the best example I can tell you that you have already learned this through ECS. So what we have done, first we have created cluster, right? So in the same way here you can say this Kubernetes master as your cluster, right? So under your cluster you will be having your instances. So here instead of naming them as instances, we are calling them as nodes or workers or minions. Okay, so this is your cluster who will be handling all your nodes or instances. Okay, so in our ECS we called this as cluster, whereas in Kubernetes we are calling it as Kubernetes master. Okay, so now we'll try to understand. We have tried to understand the master. Now we'll try to understand this node. Okay, so here you can see there will be I think this is not I think we'll take another picture and we'll try to understand this. So okay, so this is part of the master. So this we have tried to understand that this is the master. As you can see in your master, you will be having one API server, we have one scheduler, we have controller manager, and we have ETCD. I think we have already learned this one. Okay, so here you can see we have tried to understand the API server. So API server will be a main person who will be able to make the communication happen between all its components. Okay, so that is the reason I have not explained you here. I've told you example here about the functionality of the master. So as you can see, API master, this is Kube API server. So similarly, I told Cube Scheduler. So this will help you to create or delete your nodes. And one is Controller Manager. So Controller Manager. So it will be running in the background and it will check the status of all your nodes. Similarly, ETCD. So ETCD will be holding your all information, right? So this is the user interface. So the user will be trying to interact. So here we have seen the user will be interact with the master. And also I have told you that all your developers, admins, users, testers, so all these people also will be communicating with the same master only. So that is what he have told, the user is communicating with the master. And you can see kubectl. So kubectl is nothing but commands. Kubectl are the commands. So these commands, as you know, are used by the developers, testers, admin. So through these commands, these people will be trying to communicate with your master. So the master will have these four main components. So whenever you are trying to attend the interviews, so they will ask you to speak about any of the component. So they might be asking, oh, okay, in Kubernetes architecture, what is the role of controller manager? So what this controller manager will do? So what is this ETCD will do? So then you need to explain. So it is better that you can just explain them. To take one scenario, you can tell. So if a node gets deleted, so it will get prompted by the kube controller manager, will identify that there is some problem. So if there is some problem, it will go and check with the ETCD. So ETCD is the place where all the information regarding your nodes will be available. It will be cross checking. So how many should be in running state, how many should be in the closed state, all the information will be available. So here it will cross check. If it find out any difference, so what it will do, it will inform the queue scheduler to update the value. If at all two servers are there, if you need three, then cube scheduler will create one new node for you. So all this communication will happen through Kube API server. So that is why we can say Kube API server is the main brain of the Kubernetes architecture. Okay. So now coming back, now we'll try to understand our nodes. Okay. So in this nodes, we can see, now you can try to understand here. So this is very, very important. So worker node 1, worker node 2. Okay, simply what you can say is uh, you can say this as your servers: server number 1, server number 2, server number 3, server number 4. How many servers you have? Even if you have 100 servers, no problem, all your 100 servers will be controlled by this master. Okay, master is the main one who will be handling. In the master, the main component is API server. Okay, so we'll come back how this will work is, so as you know, because this Kubernetes architecture is there, right? So this Kubernetes architecture, what it need to do, it need to maintain a master slave architecture. So master should also be installed with your Kube software. So this node also need to be installed with your Kubernetes software. Okay, so these two are the softwares which will help you to communicate with your master. One is Kubelet and one is Kubeproxy. So this is the main core component which will be installed. Okay. So on the top of these two softwares, we will install Docker. So Docker is a engine for which you can run your containers. And most importantly, what you need to understand is, and in Docker engine, we have seen that the containers will be running. So this we called it as one container, container, container. But whereas in Kubernetes, the concept will be little changed. So what happens is, this worker node will handle pods. So here we can call it as pod. Okay, pod 1, pod 2, pod 3, right? So whereas in Docker, when we are working, we used to call this as container 1, container 2, container 3. But whereas when working on this Kubernetes, we call them as pods. So that is the reason we are calling pod 1, pod 2, pod 3. Now you can ask like what these pods will be doing. Okay. So these pods will be running your container. Okay. So here you can see inside each pod, one, two, three. So three containers are running. So inside similar way, pod 2. So pod 2 will have is running only one container. Similarly, pod 3. So pod 3 is running two containers. So we can say in pod is one Kubernetes unit, small unit, whereas each pod will be running your containers. Each pod can run one container or multiple containers. So basically what happens is Kubernetes will take help of is these pods for the communication purposes. Okay, so try to what you guys can do is try to explore and try to watch some like even I'll share you some PowerPoint presentations, and also I'll share some videos, and try to understand this architecture perfectly. Okay, so this is not very tough to understand. Just divide this Kubernetes architecture into two parts. One is you try to understand this master. So inside your master, what will happen? You will have, or else from here also you can understand. So inside your master, you will be having four main components. One is ETCD, controller manager, scheduler, API server. Okay, first learn this master architecture. Okay, then you can come to this node. As you can see, every node will be same only. If even if it is having 100 nodes, the architecture will remain the same. So what it will be mainly consisting of: Kubelet, Kubeproxy, and one engine. What we can say is, here we can't say that only Docker we can use. There are so many other container running engines. So Docker is also very popular one, so that is the case we are using here. And very importantly, in each node, you will be having a component called pod. So what this pod will be doing is, it will be running your containers. Okay, so it will run your containers. So each pod can carry one single container, or it can carry multiple containers. Okay, so what you can do is just you can just I think we can't cover everything in our class. So what you can do is just to find out API server and try to get the notes, make some notes, at least 4 to 5 points. So scheduler, at least 4 to 5 points. So try on each topic, try make some proper each topic at least 5 sentences. So API server, 5 sentences. Scheduler, 5 sentences. Controller manager, 5 sentences. ETCD, 5 sentences. Kubelet, 5 sentences. Kubeproxy, 5 sentences. Pod, 5 sentences. So totally one, two, three, 4, 5, 6, 7. So these 7 topics, I want all of you guys to make some notes, at least 5 sentences on each topic, and kindly submit me tomorrow. So why I'm doing this is you need to understand each specific component clearly. Then only you will be able to understand the further class. Okay. So I'll just write down and I'll keep it for you. So these 7 points I can say the 7 questions. Okay. So one is, so I'll say Cube API server. One is Cube controller manager. One is ETCD. One is Cube scheduler. One is pods, kubelet, kube proxy. I think in the node we have only 3 components. One is kubelet, one is kube proxy, one is pod, and one is we can say container engine also. Container engine might be Docker or any other software. So I need all of you guys to make these notes and kindly submit me tomorrow. Okay, so you can, what you can do is you can just what we can do in our old classes we used to ask them to make the notes. So what you can do is write notes on each topic and email me. Okay, so or else you can do one thing, or each topic and put it in the group. So please, what I am saying is, please, I'm requesting all of you guys to write the notes on this, not just preparing some notes on your MS Word or PDF file. No, try to write notes on each topic, and please paste the notes in the WhatsApp group. Okay, so I'll be reading all of your notes, and also these notes will be helpful for you now and also later also. Okay, and if the notes is good, this can also be helping your friends, such that if for example 5 people are there, 5 people will be writing notes in a different way. So what happens is you can share some knowledge with each other. If you can learn some points from your friends also. So that is the reason what we'll do, we'll share all these notes in our group only, such that everybody can read each other notes. Okay, so right now I'll put this in our group. Okay, so please kindly write the notes on each topic. Okay, so I'm not asking you to prepare the design this draw this architecture and all. Just try to understand what is this each individual component will do. Okay, so this you can just do and submit me tomorrow. Okay, and if any other thing is there, this regarding this, I think I have some good PPTs to make this Kubernetes architecture understand better. I'll also share these notes along with you. I think don't please, if you get the time, try to read this one. Kubernetes, understand Kubernetes in 100 slides. 100 slides. This was a very good PPT which I have found out. I'll share with you this with you guys. and try to read this. This will help you to understand this Kubernetes architecture very clearly. Okay, so once you complete understanding of this architecture, we will try tomorrow, we'll start working on the practical part. Okay, so how to create this Kubernetes cluster, and how to add your nodes onto the how to connect your nodes to the cluster. So that we'll try to learn tomorrow through practical. But before practical, if you are not able to understand this, you won't be able to understand the practical. Okay, so that is the reason I'll also share some notes and also PPTs with you guys. So please go through this, and also please make notes and submit in the group. Okay, so that is it for today's class. Please make these notes and submit. Okay, so we'll meet tomorrow's class and we'll do the practical on Kubernetes.